Hi, this lesson is about trigonometric functions of angles. So the sign of a trigonometric function changes depending on the quadrant that the angle lies in. The terminal side of that angle is called the radius vector r. When we were looking at this in terms of triangles, r was the hypotenuse of the triangle. So now if we think of it as something that radius is going around, and you know that when you make one full rotation, you've created a circle, and a circle has something called a radius. That's why we've been calling it r all along, because of that relationship between the triangle and the circle that's created as that radius goes around the four quadrants. So that radius vector or the hypotenuse is always positive regardless of the quadrant that r lies in. The sign of the trigonometric functions then depends on the sign of x and y, and the x will be the horizontal distance along the x-axis, and the y will be the vertical distance along the y-axis. And then remember, all of our trig functions are a ratio of two of these three sides. It's a ratio of either x over r or y over x. It depends on the trig function. So again, remembering that quick little acronym, SOHCAHTOA, helps us to remember what those relationships are in terms of whether we're using x, y, or r. So the angle that your terminal side lies in will tell you which the quadrant that your terminal side lies in will tell you what the sign of the trig function is. So when you are in quadrant 1, all 6 of your trig functions are positive. When you are in quadrant 2, sine and cosecant are positive. Remember, sine and cosecant are reciprocals of each other. So if one is positive, the reciprocal is also positive. In quadrant 3, tangent and cotangent are positive. Again, tangent and cotangent are reciprocals of each other. And in quadrant 4, cosine and secant are positive. Again, cosine and secant are reciprocals of each other. So here's a more visual way to describe that. Here are your 4 quadrants. In quadrant 1, they are all positive. Quadrant 2, sine and cosecant are positive. Quadrant 3, tangent and cotangent are positive. And in quadrant 4, cosine and secant. That means that all the other ones would be negative. So for example, in quadrant 2, only sine and cosecant are positive. The other 4 trig functions are negative, and the same is true for the other ones. The only one where they are all the same sign is in quadrant 1. So a quick way to help you remember that is in quadrant 1, all are positive. In quadrant 2, sine and cosecant are positive. In quadrant 3, t and cotangent are positive. And in quadrant 4, cosine and secant are positive. So again, that little saying might help you remember. All students take calculus. So here's an example. We want to determine the quadrant that each angle lies in and then what the sign of the trigonometric function is. So we have tangent of 330 degrees. Tangent of 330 degrees is in quadrant 4. Therefore, tangent is negative. The only 2 that are positive are cosine and secant. When I go on to B, that's the sign of negative 130 degrees. Remember, when it's negative, you're going backwards. So negative 130 lies in quadrant 3, and sine is negative in quadrant 3. Secant of 80 degrees is in quadrant 1. That's remember, quadrant 1 is between 0 and 90. So secant and all trig functions would be positive. Cotangent of 195 degrees is in quadrant 3. It's just a little bit past the quadrantal angle here of 180, so it is in quadrant 3. and therefore cotangent is positive in quadrant 3. Now let's look at some radian measures. Pi over 5. Pi over 5 is in quadrant 1. Therefore, everything is positive in quadrant 1, including cosecant. Cosine of 2 pi over 3. 2 pi over 3 is in quadrant 2. Therefore, cosine is negative in quadrant 2. Sine of 7 pi over 6. 7 pi over 6 is in quadrant 3. Therefore, sine is negative in quadrant 3. And tangent of 7 pi over 4, that is in quadrant 4, and tangent is negative in quadrant 4. So being familiar with the signs of your trig functions is something important in order to do a lot of the work and calculations that we need to do in trigonometry. All right, so here's kind of more of the same, except there's more restrictions here. Less restrictions. We are given a value for these three trig functions, and we want to state all possible quadrants where this angle may lie. So we don't know what the angle is, but we know that the cosine is this positive number, 0.8666. So where is cosine positive? Cosine is positive in quadrants 1 and 4. So theta could be a quadrant 1 angle or a quadrant 4 angle, and it would give us the same answer of 0.8666. Now I have the sine of theta is negative 0.8666. Well, where is sine negative? Sine is negative in quadrants 3 and 4. And then finally, the tangent of theta is equal to negative 0.7500. Where is tangent negative? Tangent is negative in quadrants 2 and 4. Remember, it's only positive in quadrants 1 and 3. Therefore, its tangent is negative in 2 and 4. All right, here we want to determine the quadrant in which the terminal side of theta lies, subject to two conditions. So we have two conditions given, so we have more restrictions. So where would our angle exist if both secant and cosecant are positive? Well, the only place where both secant and cosecant are positive is in quadrant 1. Then the next condition is where would the angle lie where cotangent is negative and secant is negative? Well, the only place where both cotangent and sine are negative would be in quadrant 4. So here, cotangent and sine are negative. So we know in quadrant 1, everything is positive. Sine is positive in quadrant 2. Cotangent is positive in quadrant 2 and quadrant 3. So the only place where sine and cotangent are both negative would be in quadrant 4. Then the next one is where is secant positive and cosecant negative? Well, the only place where secant is positive and cosecant is negative is in quadrant 4. And then finally, where is tangent positive and cosecant negative? That would be quadrant 3. So remember, tangent is only positive in quadrants 1 and 3, but cosecant is also positive in quadrant 1, but cosecant is negative in quadrant 3. So you want to find where both conditions are true, and that there would only be one answer for that. All right, so here's an important concept, the concept of the reference angle, and this will be helpful to you. So we call the reference angle the acute angle formed by the terminal side of the angle and the x-axis. We usually call the reference angle alpha, or sometimes this theta bar. I tend to use alpha more. So if theta is in quadrant 1, and quadrant 1 is an acute angle, because remember, acute means between 0 and 90 degrees. So if your angle is in quadrant 1, then your angle is your reference angle, alpha equals theta. But if theta is in quadrants 2, 3, or 4, then we have to find theta by doing a particular calculation. So here are our calculations in degrees. So if your theta is in quadrant 2, you find alpha by doing 180 minus theta. And then you will get the angle between the x-axis. In this case, it would be the negative x-axis and the terminal side. If your theta is in quadrant 3, then alpha would equal theta minus 180. If your theta is in quadrant 4, then it would be 360 minus theta. So you're not using 270 degrees. Notice you're using either 180 or 360. It's the same calculations when you're talking about degrees, except you're using pi and 2 pi. So if you're in quadrant 2, alpha is pi minus theta. If you're in quadrant 3, alpha is theta minus pi. And if you're in quadrant 4, alpha is 2 pi minus theta. All right, so we want to find the reference angle for the following. So this is definitely not in quadrant 1, which means I need to compute it. And 345 is in quadrant 4, so I need to use this formula. So it's 360 minus 45 minus 345 degrees, so my reference angle is 15. So let me just do a quick little visual of what that would look like. So here's my XY plane. When you draw your reference angle, you start on the positive x-axis and you go all the way around. So this entire measurement is 345 degrees. And what we're trying to find is the acute angle closest to the terminal side in the x-axis. So when I found that 15 degrees, that's this piece right here. So now let's do the next one. Theta is 230. 230 is in quadrant 3. What do you do in quadrant 3? That's when you take your angle, which is 230, and subtract 180 from it. So now I'm using the second formula. So I have 230 minus 180, and I get 50 degrees. All right, so let's move on. Let's find the reference angle for 110 degrees. 110 degrees is in quadrant 2, which means I'm using this formula. So alpha is 180 minus 110. I get a reference angle of 70. All right, now we're going to work with radians. So I have theta is 2 pi over 3. 2 pi over 3 is in quadrant 2. So if I'm in quadrant 2, I need to use this formula. So it's pi minus 2 pi over 3, which gives me pi over 3. Now I move on to 5 pi over 4. So 5 pi over 4 is in quadrant 3. And if you're not sure what quadrant it's in, you could always convert these to angles to help you. So 5 pi over 4 minus pi, I'm using this one now, is equal to pi over 4. So pi over 4 is your reference angle. Okay, now I'm on the last one. Theta is 11 pi over 6. 11 pi over 6 is in quadrant 4, so I need to use this formula. So it's 2 pi minus 11 pi over 6, which is equal to pi over 6. So that is your reference angle. So we find reference angles to allow us to evaluate trigonometric functions. When your reference angles are special angles like this, it gives you a lot of freedom. You're not completely dependent on that calculator to give you the answer. So you can evaluate these three angles, 2 pi over 3, 5 pi over 4, and 11 pi over 6, by finding the reference angle, which are here on the right, and then using what you know about the signs of your trig functions and the reference angle. Okay, so let's practice. We want to find the values of the given trigonometric functions by finding the reference angle and attaching the proper sign for each of the following. So this is just a different approach, and it's going to allow us to practice using these reference angles. So typically you could just pick up a calculator and evaluate the tangent of 311 degrees, and it will give you an answer. But you can also do it in a different way. We could find the reference angle first. So since 311 degrees is in quadrant 4, my reference angle would be 49 degrees. So remember that the tangent of 311 and the tangent of 49 degrees will almost be equal, except they're different by a sign. So 49 degrees is in quadrant 1, tangent is positive in quadrant 1, but 311 degrees is in quadrant 4, tangent is negative in quadrant 4. So therefore, the tangent of 311 is equal to the negative, the opposite sign of the tangent of 49 degrees. So if you took the opposite sign of tangent of 49 degrees, it should give you the same answer that the tangent of 311 does. Because you're essentially creating the same triangle, just in a different quadrant. So here's another example. I have the sine of 103.4. 103.4 is in quadrant 2. So my reference angle is 180 minus 103.4, which gives me 76.6. So the sine of 103.4 is equal to the sine of 76.6. And that's because 103.4 is in quadrant 2, 76.6 is in quadrant 1. Sine is positive in both quadrants 1 and 2. So therefore, no matter which one of these you enter into a calculator, it will give you the same answer of 0.97. All right, so now we are evaluating the cosine of 341.4. That's also in quadrant 4. So my reference angle is 360 minus 341.4. So my reference angle is 18.6 degrees. So cosine is positive in quadrant 4, and it is also positive in quadrant 1. Therefore, the cosine of 18.6 degrees and 341.4 will actually give you the same answer, which is 0.95. All right, now we're on the sine of 215.5 degrees. This angle is in quadrant 3. How do you find the reference angle in quadrant 3? Take 215.5, subtract 180, and we get 35.5. So the sine of 215.5 is equal to the negative of the sine of 35.5. That's because in quadrant 3, sine is negative. In quadrant 1, sine is positive. In order for them to be used, in order to compute the others, they need to be equal. So you need to put a sign in front of it. So the answer, a negative sign in front of it. So the answer is negative 0.58. All right, so let's do one with radians. I have the cosine of 7 pi over 4. 7 pi over 4 is in quadrant 4. This is how we find the reference angle. 2 pi minus 7 pi over 4, which gives me a reference angle of pi over 4. Now, cosine is positive in quadrant 4, as well as in quadrant 1, where your reference angle is. And in this case, we don't need a calculator at all. Pi over 4 is a special angle, it's 45 degrees, and the cosine of pi over 4 is root 2 over 2. Okay, we didn't have to put a negative in front of it because cosine in both quadrant 4 and quadrant 1 are both positive values, and it's the same value of root 2 over 2. All right, so here we want to find the exact value of each of the following. Exact value means we are not, this is going to be something we're going to be able to do without the use of a calculator. All of these will work out to be angles that we know. So either a 30, 60, or 45 degree angle, but they could be in different quadrants, which means the signs, the positives or negatives could change. All right, so our first one is cosine of 210. Now I say here that cosine of 210 is negative root 3 over 2. And that's because the cosine of 210 is the same as the negative of the cosine of, now if I get the reference angle of 210, that's going to be 210 minus 180, which is 30 degrees. So the negative of cosine of 30 degrees is negative root 3 over 2. And why is it negative? Because cosine is negative in quadrant 3. So let's do another one. The sine of 135. Now that, in order for me to use something I know, the reference angle for 135 is 45 degrees. Now, sine is positive in quadrant 2, so I don't need to make an adjustment for that. And the sine of 45 degrees is root 2 over 2. Now we're on the tangent of 300. Tangent of 300 is going to be negative. So I need to find my reference angle, but I also need to take the opposite sign. So 300 is in quadrant 4. So 360 minus 300 means I'm evaluating the tangent of 60 degrees. And tangent of 60 degrees is opposite over adjacent. And don't forget, it will be negative. So it's negative root 3 over 1, which is just negative root 3. Okay, now let's do one with radians. So cosine of 5 pi over 4. 5 pi over 4 is in quadrant 3. So if you were to find the reference angle, this is going to be the negative of the cosine of pi over 4. And I know it's negative because cosine is negative in quadrant 3. So here, this would be negative root 2 over 2. Okay, so now we are at 7 pi over 3. And I wrote here that the reference angle to 7 pi over 3 is pi over 3. Now, what quadrant is this in? So just as a reminder, if you're not sure of the quadrant that something is in, you can convert it to degrees, and usually that makes it easier for people to figure that out. But this one is a little bit more complicated because you have to do a little bit more work. So this is 420 degrees, which means we've gone around more than one rotation. So I'm going to take 360 away, and that gives me 60 degrees. 60 degrees is pi over 3, which is in quadrant 1. So everything is positive in quadrant 1, and the sine of 60 degrees is root 3 over 2. And then here we have 7 pi over 4. 7 pi over 4, that's in quadrant 4. And cotangent is negative in quadrant 4. So if you find the reference angle, this is the cotangent of the negative cotangent of pi over 4. And so remember, with 45 degree angles, your opposite and adjacent side are equal to each other. So this will be negative root 2 over 2. So your answer is just negative 1. Okay, so this one required a little bit more calculation. All right, so Pythagorean identities. So the Pythagorean identities, these will come up again in the course, but these are identities based on the trig functions and the angles that the trig function lies in. Identity means they have been proven to be true, so we can use them oftentimes to simplify expressions, which we will do a little bit of today, but practice again later in this course. So sine squared of theta plus cosine squared of theta is equal to 1. So I just want to point out this notation, sine squared of theta. This means the same as the sine of theta squared. and that would be true for all 6 of them. So it's typically written this way, but this is what it means, that you're taking the sine of theta and squaring that value. The second one says that tangent squared of theta plus 1 equals secant squared. And the third one says that 1 plus cotangent squared of theta equals cosecant squared of theta. All right, so we're going to use one of these to help us simplify. So here we want to simplify as much as possible. Cosine squared of x plus times 1 plus tangent squared of x. So instead of theta, I'm using x, but x here would be the angle. So you don't always have to call it theta. It's really any variable. X here would be your angle. All right, so I'm going to replace this one with that second identity. Tangent squared plus 1 is the same as 1 plus tangent squared. So I'm replacing that with secant squared. But remember that secant squared is the reciprocal of cosine. So of cosine squared. So I rewrite secant squared of x as 1 over cosine squared. Then the cosine squareds cancel, so the whole thing simplifies down to just 1. All right, so here's a formula. Make this just a little bit bigger. So here's a formula that that we're familiar with, how to find the area of a triangle. The area of a triangle is 1/2 base times height, but we're going to look at this from a different perspective using trigonometry. So let theta equals c in this picture. So c is our angle, and it is an acute angle. The triangle ABC is not a right triangle, but we can certainly create a right triangle by dropping down the height h. And that creates a 90-degree angle with the base that we usually call B. And once I do that, this part that's shaded in green, that is a right triangle, as well as the other side, but we're going to focus on this green side. So you can say that the sine of C is equal to h over a. That's opposite, that's h over hypotenuse a. So then I can express the height in terms of trigonometry. So if I solve this equation for the height is a times sine of c. So if I replace 1/2 base times height and replace height with a times sine of c, I now have a new formula, which is 1/2 base times a times sine of c. So that allows you to compute the area of a triangle if you know something about the angle, but you don't know anything about the height. So you kind of avoid having to use that value. So here we're going to find the area of a triangle, round the answer to the hundredths place. So here is our triangle. It's called RST. And I'm going to call side A ST, which is equal to 12. Side B is RT, which is equal to 18. And angle C, which was the angle that I stated above, is RTS. So it's going to be on the opposite side. So this is what I called C before. And that's given to be 55 degrees, because you really could use either one. So again, I don't know the height here, but here's my right triangle. So I'm just going to plug into this formula, which is 1/2 base, which is 18, times a, which is 12, times the sine of 55 degrees. Since 55 degrees isn't an angle that we would normally know, you do need a calculator for that. And if you plug that in, you get that your area is 88.47. I'm sorry, 88.47. We don't know what the units are, but whatever the units would be, it would be units squared, because you're talking about area. All right, so that's it for this lesson. Give the homework a try. Good luck.